Hi, I'm Rishi Naik. I'm a PhD and currently I'm working as a research assistant in School of Chemical Engineering here in University of Sydney. Since 2020, my PhD project focuses on developing spray drying and Millard conjugation strategies for plant protein functionalization improvement, which is supervised by Professor Cordelia Silamulia as well as Dr. Yong Ban here in UNSW Sydney. This project is funded by UNSW as well as a top-up from Future Food Systems. So Millard conjugation is a complex reaction, but it's based on Millard reaction. That literally is the reaction that turns your bread brown when you are actually roasting or toasting or literally baking it. So what I'm doing is I'm trying to use one of the reaction from this Millard reaction, which is like a combination of hundreds of different reactions that happen simultaneously and create different flavors, different intermediates. And I'm just trying to use one of the reaction out of it to attach a simple sugar to a protein so that it can behave much better in different functional attributes. So I guess you all must have heard about plant proteins and how they are going to be the future of protein consumption for humans. But the problems with plant protein is that they lack in functionality when they are compared to the animal protein that are commercially in the market right now. So in order to just improve the functional properties of these plant proteins, we are trying to use Millard conjugation. Now, the issue comes from the Millard conjugation is that it's a lab scale process. So it won't be able to create that much of conjugates or the reaction products that we actually need. So in order to overcome this, we have to think about some process that can go from here, that's like the smallest lab scale process, to over there. So what we are trying to do over here is to create the Millard conjugates and the reaction products on a large scale, so that we are trying to create a protocol that can make a scalable Millard conjugation using ultrasonication, spray drying techniques, as well as the other functionality improvement protocols. This whole process can actually be used if we are going to scale it up. It's going to be used in different functional and supplemental industries, as well as creating a tailored delivery system for different purposes. Some of the potential applications of these conjugates or the blends can be as a bioactive carriers. It can act as a stabilizer, emulsifier, but it needs a specific research so that it can actually be diverted into a specific combination that we are looking for. So it's based on the industry and the requirement where they can use this kind of reaction and what they are expecting from the end product. I actually envision two different parts. So first path is the academic. If I'm going to consider this as a path, it's going to be because I just want to feed the curious minds. So it's contributing my knowledge that I have gained over the years and passing it to someone so that person can actually work on developing more out of it. The other thing that I actually love is teaching. It actually gives me a kind of relief to just, teach and answer the questions of some curious people all around me. The other path that I envision going on to is the industry. It will be an interesting aspect of actually tackling some of the actual real world problems that happen in the industries. So these are the two ways that I can actually consider. So I'm actually open to all the things that comes towards my way. So that's something I think about it.